Beep. It is a 3D measurement. Which means it's got to be measured in units which are cubed. And we write that as units with a little 3 because we are covering a length, a width, and a height. Cool? Okay. Now, as I said, we have two different kinds of shapes that we have worked on so far. We have the volume of prisms, and we have the volume of pyramids. And we are going to talk about both of them first. The first thing we have to do is understand exactly what a prism is. In math class, not reality, in math class, what shape is that? Rectangle. Everyone's cool with that, right? Is this, in math class, two-dimensional or three-dimensional? What would you say? No, in reality, it's three-dimensional. But in math, it's only got a length and a width. Picking up what I'm putting down? We use this to show you guys two dimensions. Does everyone agree? Remember how I said if you put it down on the desk, it's covering a two-dimensional space. Everybody with me? So this rectangle has a length and a width. It's only got an area. Because when we draw it on a piece of paper, right? And I'm going to do this. That's the piece of paper lying down. That's how we draw it. Is everyone cool? And that has no height, does it? It only has a length and a width. Does everyone agree? This is not news to anyone, is it? Now, what happens when I stack those rectangles up? What do I get? I get a prism, don't I? Now, each one of the layers of that rectangle, each one of the layers of that prism only has a length and a width, doesn't it? But if I repeat that rectangle forever, I build a prism, don't I? So if I were to talk about how much space this rectangle is taking up, and I were to make it 3 dimensions, I would do length times width, which would give me what? What does length times width give me here? LW will give me the base area, correct? And then, as I stack that base area up, I'm repeating it for the height, correct? So it becomes the base area times the height. Now, if it's a rectangular prism, the base area is LW. Agreed? Length times width. Everyone cool with that? What if it was a triangular prism and I was stacking that upwards? Then what's my base? What's the area of a triangle? 1/2 base times height, right? Base times height of just the triangle. And then I multiply it by how many times I stack it. So I've written base area here because this shape changes. The base area is the repeated shape. So it could be a triangle, it could be a circle, it could be a square, it could be a rectangle, it could be an octagon, it could be a hexagon, it could be a trapezoid, it doesn't matter. You find the area of the bottom shape. Is it always the bottom? No. You find the area of the shape that is repeated. Base, not meaning bottom, base meaning the shape that we started with. You find that area, and then you multiply it by the height. When we draw it, remember, the height can go backwards into the page, right? That's still the height. We only call it the height because it's impossible to write if we don't call it the height. Remember? This, if it were a perfect cylinder, this is the height in reality, correct? If I drop it like this, you want to say this is the height, but that's not the case. It's this still. Everybody cool? And it doesn't matter what the shape is. If it's a prism, it is always the base area times the height, no matter what the base area is. Cool? All right. Now you guys are smart kids. How does a pyramid differ from a prism? Sean? A pyramid goes into a point, right? So if I draw in black a prism, you can see that all that is solid, yes? And if I were to fill that up with water, the water would cover everywhere inside. Agreed? That would be the volume. But if I put a pyramid in there, it comes up to a point, correct? So what is all of this if I put a pyramid in there? Empty space. So it's got no volume, does it? So you can see that this red pyramid has the same base as the black prism, correct? So a pyramid's volume must be related to a prism's volume. Agreed? Antonio? Don't say it yet. Does everyone agree that they have to be related because they start from the same shape? Yes? So the volume of a pyramid must again be the base area times the height, but you can quite plainly see it's not going to be that size, is it? Right? So what is the only math we can do that will reduce this answer to a lesser volume? I have to do subtraction or division, don't I? So that's the only way to get smaller, yes? Everyone agrees? Okay. So through experimentation, our good friends, the Egyptians, the Greeks, and the Indian mathematicians figured out that every pyramid has the volume of its related prism divided by 3. Always. Through experimentation. The other way we write it is this: 1/3 area, I meant to say base area. 1/3 base area times the height. Okay? Everybody with me? So you do the same thing, base area times height, and then you divide by 3 at the end. Is everybody good? Yeah? Okay. So what does it say to do? Return to the previous 5 questions and do the volume. So you guys have those in your book already. And we're going to do the volume of all of them. Now, hopefully you left a bit of space, because volume doesn't take up as much room as surface area, does it? Which is weird, because volume is the one in reality that takes up room. So we're going to go back here, and I'm going to work in blue for volume. So let's go back to the cereal box. It's a few pages back for you guys. Mattios. And have a look at that. Is it a prism or a pyramid? Prism. So the volume is, you don't have to write this out if you don't want to, base area times the height. Now in this case, the base area is a rectangle, isn't it? So what's the area of the base? LW times the height. So I just put in the numbers. 24, 8, 40. Does order matter in multiplying? No. Goodness gracious. You all saw that disappear, right? It was written there, yeah? And it still disappeared. Ghosts in the machine. Shh. No, I didn't. Because I disabled my touching on the computer. I can't use this computer like an iPad because I disabled it. See? Touch doesn't work with my finger. I hobbled it. But I don't know what the heck happened there. So it's 24 by 8 by 40. Now, I cannot do that in my head. I wish I could. Actually, I think I probably could. 8 times 40 is 320. 320 times 20 is 6,400. 4 times 320 is 1280. 6,400 and 1280 is 7680. Is it? 7680 watts. What cubed? Right. Centimeters cubed. Why is it cubed? Cassie? 3 dimensions. Everybody cool? All right. Turn the page over. And that's how easy volume is. There's nothing to it. There's no trick. That's how easy it is. Pyramid. Pyramid is volume of a pyramid is still base area times height. What's the divided by 3? What's the base of this pyramid? What shape? Right. It's a rectangle, so it's 32 by 48. And what was the height of my pyramid? 65. And then what do I do with that whole answer? Divide it by 3. You can punch out in your calculator exactly as you see it. I'm going to write in red the buttons you would use. You would simply go 32 times 48 times 65 divided by 3. Nothing special. Doesn't need brackets, doesn't need anything special. You can punch that in just the way you see it. And what do you get for an answer? That one I'm not doing in my head. 22,000, 26,000, 346 point, so 7 will be fine, or 0.67. Is everybody cool? Time to check. Time to check. 32. Oh, wake up, computer, calculator. 32 times 48 times 65 divided by 3. I get 33,280. What were you doing? You got 33,280 or you got your number? Did everybody else get 33,280? Feet cubed. I don't know what to tell you, Antonio. You can puzzle that out. Well, you're... well, that will screw that up there, won't it? Now, cone. Is a cone a pyramid or a prism? It's pyramid because it goes to a point, right? So the volume of a cone is the base area, again, times the height, yes? But what's our base area now? It's not length times width, is it? What is it? It's a circle. What's the area of a circle? Pi r squared. So it's pi r squared times h. Pi, what's my r? So in this case, what is it? 15 squared times what's my height? 22. Now remember, I like you to leave pi there alone, right? So what are you going to do first? Are you going to do anything with pi? No, you're going to do 15 squared times 22. Now most of you on your calculator have this button, x squared. That's what you hit. So you're going to go 15, then the x squared button, then times 22, and equals. And what's that going to give you? Pardon me? 4950 pi. And that's where you're going to leave it for whom? Me. But what if you're doing a multiple choice test that doesn't have that? How do you finish this question off? What do you do with 4950 and pi to find the right answer? Oh, I'm sorry. To find the answer that might be on the test. Yeah. You do 4950 times your pi button to get whatever the answer is, which in this case, in case anybody's following along at home, 4950 pi 1550. Then what? What? That's not the volume, because you got to do one more thing. Right? What do I got to do with that now? With the pyramid, what did we do last? So we either got to divide by 3 there, or we divide the 15,500 pi, whatever it was, divided by 3. I got to remember to divide by 3. I didn't here because it's a pyramid. Cool? Got to divide by 3. Can you leave it like this? It's fine. I don't care. Because again, what am I here for? Concepts. I want you to understand concepts. All right? And how many have we done now? 4? 3? I can't remember. Where are we here? That was the last one? No, we got one more. We've done 3. So now all we got to do is the cylinder. Is a cylinder a prism or a pyramid? Why is it a prism? Doesn't go to a point. It's stacked circles, yes? So it's base area times height. Do I care about dividing? No, because this is not a pyramid. We already know the base area is a circle, so it's pi r squared h with no dividing. What's the radius? 5 squared. What's the height? 20. So it's 5 squared is 25 times 20 is 500. So this is 500 pi. Can we leave it like that? For me, yes. On a test, depends on the test. Everybody Gouda? Great. So now that we're good with volume and surface area, it's the weekend, yeah? So, what if I cut you guys a break and just give you a bit of textbook work, and I give you 20 minutes to work on it, so you have no homework for the weekend? Sound okay? All right. So how about we go to page 42. Oh, one sec. Just let me check something. I don't want to do that yet. So we are going to go to page 42. And let's go with two Q's from section A, three questions from section B, and one question from section C, which is on page 44. Okay? Section A is numbers 4, 5, 6, and 7, I think. So you do any two of, is it 8 too? And 9. Okay. So any two from 4, 5, 6, 7, 8, 9. Any three from section B.
So if we do like an A 4, then we have to do A and B. 4, A and B.
Oh, of course, yes.
Okay.
Yeah. Yes. Everybody cool with that? Check your own answer in the back of the book. What do you do if you're getting different answers than the back of the book? Check with whom? There's 30 of you. Can I help all of you at once? Oh, Antonio, stop it! You're making me blush. No. Check your notes first. Check with someone you're sitting with, and you can move around, of course. If between the two of you, you cannot figure out why your answer is different from the back of the book, then what do? Then you talk to me. But remember this, you're smart kids. If two of you are looking at the math and you've done the math right, remember, the people that do the answers in the back of the book are humans like you and me. Do they sometimes have fat fingers on their calculator? Yes. Do they sometimes have fat fingers when they're typing it in before it goes to the printer? Yes. Does spell check correct numbers? No. So there is a lot of wrong answers in the back of the book. Not a lot, but enough that you need to be confident in your work. Do you understand what I'm saying? So let's say you talk to a friend, you get the complete wrong answer, but I'm busy with some other kid. Just go on, because the chances are better that you've done it right. Picking up what I'm putting down? Okay, go! Is that enough time to get 6 questions done? I think so. 20 minutes, 3 minutes a question. And if you don't get 6 questions done, I'm giving you 2 days to do it. Zach, if you leave that chair back there today, I'm going to do something drastic. No, you did not, Zach. You have left it back there every day. When? Yesterday?
Yeah. And sometimes it's here when I get here. Yeah.
Sometimes it's there when you get here because the other class is here, Block A. And I've given them the same speech. You did not bring it back yesterday. Because the kid in Block A was like, where's my desk? Well, maybe it was the day before. Where's my chair? Shut up! Josh, Meanie. Antonio, say something nice to me now because I'm feeling hurt. Thanks, buddy. Yes, go. Oh, are you leaving the room? Fill that with water for me. Thank you. You're the best. Don't let anybody tell you different. Oh, I recorded all that.